Continuing on, using stoichiometry in the mole island to solve simple stoichiometry problems. We are now going to work on example number 3. Example number 3 is a little bit different. It says how many moles of oxygen are needed to produce 8 moles of water. So my chemicals are different this time. Now let's identify our stuff, and they gave us a formula, so that's a bit different also. So the known again is still whatever they provide you with the number, the unit, and the chemical. So the known is 8 moles of water, and it asks me how many moles of oxygen. So question mark mole O2. That's the unknown. Now this one looks different. This one is saying I'm converting chemicals here. You see that I have mole and mole, units the same, and then I have different chemicals. So let's take a look. These are your units. This is where your mole island starts to become very handy. It's even more handy in multi-step problems, but these are your units. And this says mole and mole, right? Mole, mole. Substance A, water. Substance B, right here, oxygen, right? So I'm going to use my mole, it's called a molar ratio. We're going to use the coefficients from the balanced chemical equation. That one doesn't really help us with the equivalency. But here, remember I helped us out with the equivalency? So we have the numbers of mole A, which is going to be a chemical, is equal to the numbers of mole B. And the numbers I get from the coefficients from the balanced chemical equation. So let's set that up. It's not nearly as scary as it sounds. Right? I'm going to do a little fraction line. It tells me, I usually just write mole and mole because I know it's going to be moles. Chemical A is water and chemical B is oxygen. Then I gotta go up. Look, they gave me the balanced reaction though, so thank you. There's 2 in front of water, and there's a nothing in front of oxygen, but it's not nothing. It's understood to be 1. So 1 it is. I've just created my conversion factor to get from moles of A to moles of B, or moles of water to moles of oxygen. The known is the same. I'm going to set up a fraction and put it over 1. I'm going to multiply it times another fraction, which is my conversion factor. So I'm going to, just as a reminder, here we go. We're in step 2. We're going to write the known as a fraction, and then step 3, we're going to write the conversion factor as a second fraction and arrange so like terms cancel. So I'm going to do 8 mole water, right? My units are exactly the same. I'm not canceling out the units. The thing that is different this time is my chemical. So I have to cancel out the chemical. I'm going to match my chemical, whatever here is a numerator, I'm going to put it down here as a denominator. And therefore 2 moles water is going to go on bottom, and then 1 mole oxygen on top. I'm going to cancel my like terms. Mole water cancels. Now this math I can do in my head. I've got one significant figure. 8 times 1 is 8. Divided by 2 is 4. So 4 moles oxygen. So if I have 8 moles of water that I produce in the reaction, I'm going to be required to put 4 moles of oxygen into the reaction. And that is example number 3.